All right, so what's the distribution of a random variable, in particular for discrete random variables? Let's consider the discrete case for a while now. We're going to stay in the discrete cases for a while. So for example, let's let big X, we usually, by the way, we usually reserve our uppercase letters from the end of the alphabet to denote random variables. So let's let big X denote the number of siblings for a person chosen at random. Okay, the number of siblings for a person chosen at random. Then maybe, probably not. Okay, some people have 6 or 10 or 15 brothers and sisters, whatever. But maybe we can think of it like this. Maybe the probability that this number of randomly chosen, the number of siblings for a random person, the chance or probability that that number takes on the value of little x, the chance that number takes on, say, the value of 0 is 20%. Or maybe the chance that it's 1 is 45%. Or maybe 8% of the people have 3 brothers or sisters, and 5% have 4, and so on. Okay? So what is the distribution? It's this whole thing right here. This is the distribution. Distribution is two things. It's two things. One, it's a listing of all the possible values that variable can take on. Okay? Or it may be, you could write it as a set, or an interval, whatever. It's a list of all the values that variable can take on, and a list of all the probabilities that variable can take on. Okay? That's what a distribution is. It's two lists, effectively. It could be represented this way, or as a graph, or whatever, but it's two pieces of information. One is the list of all the possible variables values it could take on, and along with their probabilities. Okay? Now let's take a look at one more thing here. By the way, one of our probability axioms says what? That we must get an outcome somewhere in the event space. Okay, so how do you think that translates to random variables here? What does that say about these numbers here? It says that that along with the fact that they're disjoint. Events, you can't have 2 brothers and sisters and 3 brothers and sisters. These numbers must sum to 100%, right? Do they? 85, 95, 100. Yeah, 100%. Good. All right. So let's do another example here. Each of 4 balls is randomly placed into 3 bowls. 1, 2, 3 bowls. 4 balls. Okay, we've got ball number 1, we've got ball number 2, ball number 3, and ball number 4. Okay, there are 4 distinct balls placed in 3 distinct bowls. Okay, and they're dropped randomly in. So the chance that ball 1 winds up in this bowl is 1/3. The chance that ball 1 lands in this bowl is 1/3, and the chance that it lands here is 1/3. So let's let X denote the number of empty bowls. After we do this, we've got 4 balls, we're going to drop them all in here. Okay, so maybe I'll help you get the first one. What's the probability that X equals 0? What's the probability that there are no empty bowls? Okay, well, first of all, I don't know, but first of all, let's count up the number of ways I can drop the distinct balls into the distinct bowls. Any thoughts on that? How many ways can I just drop the balls into the bowls? You ready? I think it's 3 to the 4th. Okay. Now, how many ways could I actually drop the balls into the bowls so that I get no empties? Well, that means I'm going to have a ball and 2 balls in one bowl, right? There will have to be 2 balls in one of the bowls, and then each of the other bowls has 1 ball. Right? So how can I do that? Well, here's the way I think about it. Maybe you want to pause right here and think about it. Okay, I'm going to go ahead and do it now. This is the way I thought to do it. I'm going to pick 2 of the balls to go together in a bowl. How many ways could I do that? Or choose 2. Okay. Once I do that, I know that I'm going to take the other 2 balls and put them in the other 2 bowls, maybe. Okay, so maybe I've got 2 here. 1 here, 1 here. Now, once you have done that, how many different ways can you arrange the 1, 2, 3, collections of balls? Well, there's 1, 2, 3, 4, 5, 6 ways. Could you see that? 6 ways. It's 3 factorial, folks. 3 factorial. Okay. Now, maybe you could try to get the others here. For if you want to pause and go ahead and try to work it out on your own. Okay. I'm going to show you what I got here, though. Ready? I got, for this one, I got, it's all over 3 to the 4th, 3 to the 4th here. I got 4 choose 2 times 3 factorial times a half plus 4 choose 3 times 3 factorial. Boy, this one was kind of tricky. The last one is just 3 over 3 to the 4th. Hey, what's the chance that x equals 3? Guess what? It's 0. That's impossible. And impossible events must have probability 0. Okay? Can't have 3 empty bowls. All the balls are going into the bowls. Unless you meet and you just miss all the bowls. But, okay. Now, I think you'll find that if you add all of these numbers up, you'll get 100%, or 1. Okay? So, what is the probability distribution for x? Well, it's going to be these numbers, 0, 1, and 2, along with these probabilities. You should probably work these out. Okay? Maybe I could work them out here without too much trouble. 4 choose 2 is what? That's 6. This is 6 times 3 factorial is 6 over 3 to the 4th is 81, I think. This is 36 out of 81, isn't it? Okay. What is 4 choose 2? 4 choose 2 is 6 times 6 is 36 times a half is 18. This is 18 plus 4 choose 3 is 4 times 6 is 24. This works out to be, I don't know, 42, I think, and 81. Hope that's right. And then 3 over 3 to the 4th is just, well, let's keep it as 3 out of 81, okay? And can you check that then? Then you get 3 plus 42 is 45, plus that is 75. That's 81 out of 81 if you add these numbers up. Very good. You guys are so smart.